this video, we are going to discuss about LCR parallel resonance. So here the circuit looks like this. Okay, so you have inductor followed by a resistor, and which is in parallel with a capacitor. Okay. So this is a current and this is the AC voltage. So I can write this impedance as so I can write this this is nothing but your Z1 and this is nothing but your Z2. Okay, so I can write 1 divided by Z is equal to 1 divided by Z1 plus 1 divided by Z2. Okay, so this I can write it as 1 divided by j omega L plus R plus 1 divided by j omega C. Okay, so this I can write it as 1 divided by j omega L plus R, okay, plus j omega C. So I am going to multiply and divide by R minus j omega L. So if I multiply R minus j omega L for this term alone, I will get R square plus omega square L square plus j omega C. Okay, so I am going to separate the imaginary term and real term common. So if I do, I will get I'm going to take j common. Okay, if I take otherwise if I take minus j omega common, I will get L divided by R square plus omega square L square minus omega minus C. So we know that for the resonance, the imaginary terms becomes real, right? So at resonance, that is reactance. This is nothing but reactance, right? Reactance part is actually a susceptance which is equal to 0, right? So I am going to equate this whole term to 0. Okay, so if I do like this, I can write R square plus omega square L square is equal to LC. Thank you. Sorry, L by C. So I can write if I want to find the frequency, omega square L square is equal to L by C minus R square. Okay, so omega square, if I divide the whole term by L square, I will get 1 divided by LC minus R square divided by L square. So omega is equal to root of 1 divided by LC minus R square by L square. So F is equal to 1 divided by 2 pi root of 1 divided by LC minus R square by L square. Okay. So this is your second equation. So next you need to find the value of the dynamic resistance. Okay. So since I have equate this imaginary term to 0, so if I equate this imaginary term to 0, what is 1 divided by z? 1 divided by z is equal to r by r square plus omega square L square. This is your first equation, and this is your second equation. R square omega square plus L square. So okay, this is from equation 1. Okay, so what is r square plus omega square? R square plus omega square L square is equal to L by C. Okay, so this is L by C. So this is your from equation 2. So I will change this to 3. So I can write dynamic resistance. Okay, dynamic resistance Z is equal to L divided by R. Oh. So this is your fourth equation. Next, I want to find the bandwidth. Okay. So you can see, since it is a parallel resonance, Z value will be maximum, right? So the Z value is maximum, and we need to find the value only at this point, right? This is your F1 and this is your F2. Okay. So this is your 0.707 of this one. Okay. So if I take this as Z max. Okay. So this is 0.707 of Z max. Okay. And sorry, this is nothing but ZT. Okay. Here the notation I have changed. This is your ZT. ZT is a dynamic resistance. Okay. So if I want to equate, I can write first what is Z. Okay. So 1 by Z is equal to 1 divided by R plus J omega L plus 1 divided by Z. 1 by J omega C, right? So this I can write it as R plus J omega L, R plus J omega L, and 1 divided by J omega C are in parallel, right? R plus J omega L plus 1 divided by J omega C. So this J omega C I'm going to multiply it inside. Okay. So R plus J omega L divided by j omega c r into j omega c minus omega square LC plus 1. Okay. So here if you compare to omega L, R value is very less. So, okay. So I can ignore this R. So Z is equal to j omega L divided by j omega RC minus omega square LC plus 1. Okay. So if I take modulus, I will get omega LC L divided by root of omega RC whole square plus 1 minus omega square LC the whole square. Okay. See, I am going to multiply 1 divided by omega RC. Multiply and divide by 1 divided by omega RC on both terms. So if I multiply omega RC, I will get like this. Okay. So this is equal to L divided by RC by omega RC. Okay.
Get this. The thought. It's in the bun. Please.
This is nothing but omega square R square C square plus 1 minus omega square LC whole square. Okay. So what is Z? Is it at 3 dB frequency? Since I want to find the frequency, right? So the modulus values, this is nothing but if I take modulus, I will get ZT of root.
Yeah.
So I am going to take this is ZT of root. So I am going to equate the denominator first. Okay. So here ZD is 1 divided by LRC. So I can write 1 divided by root 2 is equal to omega RC divided by root of omega RC the whole square plus 1 minus omega square LC the whole square. So this I can write it as if I square this term, I will get omega RC square plus 1 minus omega square LC whole square, that is equal to 2 into omega RC the whole square. Okay. So if I bring this term here, I will get 1 minus omega square LC the whole square is equal to omega RC whole square. Okay. So I can write this is 1 minus 2 omega square LC plus omega power or otherwise I can write like this. Okay. So if I take square root, I will get plus or minus omega RC. Okay. So I'm going to bring this term to the left hand side. I will get 1 minus omega square LC plus or minus omega RC, that is equal to 0. Okay. So if I multiply minus on both sides, I will get omega LC plus or minus omega RC minus 1 is equal to 0. So if I want to find the value of omega, to find omega, omega is equal to minus b. Minus b is here plus or minus rc plus or minus b square. B square is omega rc the whole square minus 4a. Okay, 4ac, right? Divided by 2a. Sorry. Two a is 2lc. So if I solve, I will get plus or minus rc plus or minus root of r square c square plus 4lc divided by 2lc. Consider for omega 1 it is minus rc plus or minus root of r square c square plus 4lc divided by 2lc. For omega 2 it is rc plus or minus r square c square plus 4lc divided by 2lc. So we know bandwidth. What is our bandwidth formula? Bandwidth is equal to omega 2 minus omega 1. So we will get rc by 2lc minus rc divided by 2lc. So this is equal to rc divided by l. Oh, sorry, and I see it. So this is something but r by. So this is your bandwidth. So from this one you can see this is similar to that of series resonance, right? So Q becomes what is Q? Q was nothing but omega naught L divided by R. That is equal to 1 divided by omega naught CR. Okay. And if I want to find the value of a voltage across the capacitance. Again, so voltage across the capacitance. So what is the voltage across the capacitance? That is I into 1 divided by j omega c. Okay. So at resonance we are going to take the modulus. So I divided by omega naught c. So what is omega naught? Omega naught is equal to otherwise I can write I is equal to voltage across the capacitance voltage across the capacitance into omega naught c. Okay. The thing cancelled. Okay. So we know that the current and the current flowing through this current at resonance that is equal to V divided by RD. Sorry, SRT. Okay. V divided by SRT at resonance. So resonance value is L divided by RC, right? So L divided by RC. So I is equal to VRC divided by L. Okay. From this I can write V is equal to IL divided by RC. Okay. So if I consider the V is my input, since it is parallel, okay, V and VC are same. So since V and VC are same, V and VC are same, you can see the diagram. And if this is V, the voltage across this one is VC. So V and VC are same. So therefore, I can write IL divided by RC into omega naught C. So this is the current that is flowing through the capacitance, right? So IC, okay. So IC is equal to IL divided by RC into omega naught C. Okay. So this I can write it as C get cancelled out. So what is omega naught L divided by R? That is nothing but Q into I. Okay. So IC is equal to Q into I. In similar way, I can write IL is equal to Q into I. So here Q is nothing but 1 divided by omega naught RC into I. If I want to solve this, some other equation. Okay. So how to solve? IL is equal to, otherwise I can solve VL is equal to IL into omega I. Okay. If I take modulus and omega naught L. So what is IL? IL is equal to VL divided by omega naught N. So here VL is equal to V. Since we have taken omega L values greater than the R, so the voltage across this one is this is IL divided by RC into omega naught N. Okay. So this is equal to I divided by omega naught RC. Okay. So IL is equal to Q into I.